All right, so today we're going to look at our third lesson on different types of algebraic patterns. These problems I'm showing you are definitely not the only types of kind of pre-algebra you can do with your students. They're just some ideas. If you haven't already, make sure that you've printed out or at least have access to viewing this handout right here, the ratios and number combinations and pastures handout. All right, so let's look kind of at these and look at maybe the difference between these and what we did before. So here we have a table where we have two unknown values. Okay, so I wanted to make sure that we looked at some like this too. So notice in this one there are 17 total antennas. That's all we know. And so then how many Zims and how many Zifs, that's what we're calling these weird little alien creatures, would be on the ship. Notice we can't really even do a system of equations here because although we have two variables, how many Zims are there and how many Zifs are there, we don't have two equations. The only thing that we know is that the antennas add up to 17. We weren't given a second equation like how many creatures there were, how many aliens there were. So we're kind of have to do a guess and check method. So what I like to do is I like to start with the one with the biggest value. Okay, so and I like to start with the first possibility. So notice there could be one of these guys, which would make two antennas, right? Notice the total number of antennas has to be 17, so we already have two taken care of, which means there must be 15 antennas. Because these only have one, there must be 15 of those guys. Okay, so that's one option, but it's only one of those options. So let's go back here. Notice in this case, I'm kind of making this one the independent variable, and then I'm changing this one accordingly, making it the dependent variable. So if this was 2, I would have 4 antennas, okay, leaving 13, which means there are 13. So we can kind of keep going here. So we would leave 11 here. Okay, so notice once you establish a pattern, we're going up by 1 here, and that is causing us to go down by 2 here. So we can count kind of all the way up if we want. You can also use the ... notation as long as you kind of list the last one. So here we're going to have 8, 10, 12, 14, 16. Okay, notice we have to stop at 8 because if we had 9, we'd have 18 antennas, which is already too many. And then this is counting down by 2s. And notice in every row, we do definitely have that the number of antennas adds up to 17. Okay, so on these, notice we're having to come up with multiple scenarios. All the scenarios that would work, I would want you to list in something like this. So let's try that same method out on this second one. So notice these guys have 3 antennas, these guys have 2. So I'm going to start off thinking about 1. But if you think about it, if you have one of these, then you're going to get an odd number of antennas, which is never going to work here. So you can kind of by trial and error figure this out or realize that actually this is going to need to be an even number because 2 times 3 would be 6, right? And then we would have 34 left. We need this to be an even number. We need both of them to be even, essentially. And so then we would have 17. We need both of the antenna numbers to be even, rather. So if we go up by the next even number, that would give us 12 here, right? If we take that away from 40, we have 28 left, which means we had 14 of these. Let's do one more, and then I think we can establish a pattern. 6 times 3 would be 18. That would leave 22 over here, so that must mean 11 creatures. So now notice, if we treat this again as the independent variable, we're going up by 2s here, we're going down by 3s here. So I think we can kind of keep going until basically we can't go up anymore. 12 would be the most we could have, right? 12 times 3 is 36. If you go higher than that, you have more antennas than you can have. So this would be 24, this is 30, this is 36. So notice if you treat this like an independent dependent variable thing, then it takes some of the guess and check out of it. Okay, because if we know what this is, then we can figure out what the dependent variable is after that. So I want you to pause the video and see if you can do the third one, and then we're going to do the final one together. But go ahead and pause the video and see what you can do about this 28 antennas with the snoofs and snuffles. Okay, I just made up all kinds of words. So go ahead and pause that video. All right, but when you come back, notice that we're only going to be able to do certain numbers here. So if we make this the independent variable again, if we have one of these, notice that leaves 23, which is not divisible by 3. Okay, so 2 will work though. Okay, because 2 times 5 is 10, leaving 18, right? 18 is divisible by 3, which means we have 6 of these guys. So notice, try 3 out. You'd have 15 antennas, right? You can write this out too and just kind of cross them out if you want. In other words, you can do this if you want to. You can say, okay, if I try 3, I'm going to have 15, which will leave 13, and I don't know what'll go there, so that doesn't work. Okay, so as you're kind of working through, you can do processes like that as well. Notice 4 would be 20, leaving 8, which is also not divisible by 3. And then if we go to 5, we'd have 25. So it looks like that's another one, right? So if we had 5 here, we'd have 25, leaving 3. And so we can only have one of these. Notice now we know it's time to stop, right? Because there's nothing lower than 1 that we can go. You have to have at least one of every creature. Okay. All right. So last but not least, this last one is a little bit different. Notice this actually gives you a little bit more information. It tells you how many creatures there are as well. So you actually can set up a system of equations here. So I want to show you how you could do that, but then I also want to show you how you could show pre-algebra students how to solve this, because pre-algebra students aren't going to know how to do a system of equations. They're not going to know how to solve that. They don't learn that till about Algebra 1, sometimes 8th grade math. All right, so if we call these guys the x's and these guys the y's, okay, then notice that we would have 24 total creatures. Okay, so we have one equation based on creature number, and then we have another equation based on antennas, right? So every one of the x's has 5, every one of the y's has 6, and we know that those equal 131. Okay, so like I said, if we had the means to be able to do this, our students could use a system of equations. That's not how I'm going to do that here, and I want to show you how you can use other methods if maybe that's not something that you have learned yet, or if your students forget it, or maybe if you've forgotten it. So the first thing I like to do is just kind of guess, okay? What would be the even breakdown of 24 creatures? So I'm just going to guess and say, okay, maybe there's 12 and 12. Okay, and then I'm going to anticipate or figure out how many antennas I have from that. So notice if I multiply this by 5, I get 60. And if I multiply this by 6, I get 72. So if I want the total, I have 132. Okay, notice this is really close to what I wanted, right? I wanted 131. So this is just one too many. Okay, so while this is not our answer, I think this does lead us to what our answer might be, right? We just actually need to reduce the antennas by 1. In other words, we need less of these guys and we need more of these guys. Notice they are 1 antenna apart from each other. So we need maybe 1 less of these guys, which is going to automatically make us have 1 more of these, because remember, these have to add up to 24 since there's 24 creatures. So let's check that out. So 13 times 5 is 65. 11 times 6 is 66. Okay, and notice these do add up to 131, so we can put a check mark there. So this is actually our answer here. Okay, so notice I just randomly guessed basically an even distribution of both types of creatures, and then I adjusted from there. Okay, you also could use this and solve this if you wish. Okay, but you would end up getting the same result. So, but remember, I'm trying to teach you, the concepts that you would be teaching junior high kids for the most part, and they're not going to know how to do a system of equations until a little bit later. Okay, so that's kind of the alien questions, so you'll have some of those for homework. So now let's look at these pasture problems. I don't know why, but these are one of my favorites. They're fun. I actually think you can do these at the elementary level or the junior high level. It doesn't really create, it doesn't require upper level math. It actually just requires like addition, kind of trial and error, and maybe a little bit of patience. Okay. So notice on this one, I give you a hint that orange is 5. So let me set this up first. So we have all these pastures, okay, and then the bridges leading from pasture to pasture, and there has to be cows in each pasture. And the bridge tells you how many cows are shared within 2 pastures. So that means between purple and orange on this one, there's 8 total. We just don't know how much the makeup of each pasture is. Between purple and yellow, there has to be 9. Between yellow and orange, there has to be 11. So notice when I give you the hint here, this is really easy to figure out, right? So if I were dealing with, younger kids or maybe just introducing this topic, I might go ahead and tell them. Let me write with a pen because I don't think that's very dark. So if there are 5 in the orange pasture, then that kind of lays out what everything else is, right? So if there are 5 here, then there must be 3 here because 5 and 3 together have to be 8. And then if this is 3, this has to be 6 because 3 and 6 have to be 9 for the bridge. And then you can kind of check it the other way. Is 6 and 5 11? Notice it is. Okay. So notice all the ones on the left-hand column, I give you some sort of hint. But the hint's really not necessary. You can actually work this out anyway. You can work this out without it. So let's take a look at this guy. So how would you work it out without? Well, the first thing I do is I focus on the smallest number that I have. And I realize that there can't be 3 cows in this pasture because that would mean there would be none in the yellow. Okay, so I only have 2 options, right? I only have 2 or maybe 1. So I'm going to write kind of lightly here. So notice if I have 2, that means I have 1 here and 4 here, and that doesn't work. Okay, so it must mean it's 1, and this would be 2, and this would be 5, right? Notice 1 plus 5 is 6, 5 plus 2 is 7, 2 plus 1 is 3, so we're good to go. Okay, so usually with just a little bit of trial and error, especially if you focus on the smaller number being your independent variable, you should be able to solve these. All right, so let's go on to the next one. So these are just fun little thinking puzzles that can kind of get students used to thinking about patterns. I wouldn't necessarily teach this as a standalone topic. I would include it with some other patterns, but it is a fun activity that students like to do. So again, I would focus on the smallest one. Okay, so we know it can't be 5, so the yellow has to be either, and purple too for that matter, either 1, 2, 3, or 4. Okay, so just try it out, and you can kind of pause the video maybe. Why don't you pause the video and see if you can do these too, okay, and then we'll kind of see if we have them. And so the pattern that ends up working out with some trial and error is if this has 2, this must have 3, and then this must have 6. So notice 3 plus 6 is 9, 6 plus 2 is 8, 2 plus 3 is 5. Okay. Again, always focus on the smaller one. So here we have 7. So the only choices for both of these pastures is 1 through 6. Okay, so not an incredible amount to try. The one that ends up working is 5, 2, and 6. 5 plus 6 is 11. 5 plus 2 is 7. 2 plus 6 is 8. Okay. It's a little more challenging when we get to the ones that have a diagonal bridge. Okay, so just so you know, the diagonal bridge is only linking like these 2 pastures. This one is only linking these 2 pastures, and so on and so forth. Okay. So again, you want to start with the one with the smallest amount. Okay, so this one has 4, which means it's either going to be 2 and 2, or it's going to be 3 and 1, or maybe switched, right? 1 and 3. Okay. So if we try 2 and 2, I'm going to do it lightly because it might not work. That would mean this would need to have 3, and we already have a problem, right? This diagonal is not right, so it's not 2 and 2. So we'll try 1 and 3. So again, if we put 2 here, again, that diagonal is not right. So rather than coming up with equations, I think it's quicker just to trial and error this. So 3 and 1 looks like it's going to be the choice, right? Which means this is 6, and then this must be 4. Okay, because 1 plus 4 is 5, 4 plus 6 is 10, so on and so forth. Check everything, but also the diagonal works. Okay, so the diagonal just adds kind of one other element of checking. But again, I still think these are pretty fun, easy problems to work. All right, so last but not least, let's look at this diagonal. Okay, so if this is 5, that means we don't have a lot of choices, right? It's either 4 and 1 or vice versa, or it's 2 and 3 or vice versa. Okay, so I want you to pause the video and see if you can work that one as well. And then we'll come back together and see if we've got the same answer. There's only one way that these work, guys. So you just need to try it until everything works. Everything lines up. So what's going to work here is 4 and 1. And then that makes this a 6. And then this a 5. Okay, and it looks like everything else works as well. Okay, so your homework is going to be much of these same kinds of questions. Okay, so I want to talk to you about your homework this week just to make sure everybody's on the same page. So the first assignment is going to be something like these. Okay, it's going to be some alien problems and some pasture cow problems. But then it's also going to be a project assignment where you're supposed to create your own kind of scatter plot lesson. So if you have any questions about that, definitely email me and I'll get back to you on that. But I want some really good lessons, guys. Like I want something that is something that you think you might be able to use in your future classroom. So if you plan on being a junior high teacher, try to focus on a problem that is more junior high based or leveled. If you plan on teaching high school, try to make it a little more challenging. Okay. But either way, no matter which one you pick, you are allowed to use technology in your in the problem that you choose. So you're allowed to use the scatter plot curve of best fit off the calculator if you need to. Okay, so email me if you have any questions. And then as far as getting ready for the test next week, I already have the review up, so you could go ahead and be starting to work on that as well.